I should have been recording. All right, no problem. So, yeah. So, look, if we realize, let's start the stopwatch when it's reached. When it reaches here, we're going to start the stopwatch and look what happens to the time it takes to complete, say, 5 oscillations. Let's look at the time. All right. So we start here. One. Wait, it wasn't starting. Okay, let's try again. So start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So this is 14.
14 seconds.
Right. So 14 seconds to complete 10 oscillations. If we
Yes,
increase
sir.
the length to 1, let's try that.
Whoa.
So we realize that it's moving a lot slower, right?
Yes, sir. Because of the distance.
Yeah. So we now started walk over. Let's try this again. All right, we need to. Let me stop it. Place it back at 15. Let's try again. Okay. Start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So you realize it's taking a longer time.
20 seconds.
Yeah, so
Yes.
at first it was 14. Now it is at?
Take an additional 6 seconds
Yeah. All
more.
right. So are we all seeing that?
Yes,
Yes,
sir.
sir.
All right. Another thing that affects the simple pendulum is the angle that we place it. So we originally placed it at 15, right? Now, what if we place it at 70, right? And let's put this back down to 0.7. Let's put it down to 0.7, right? Wait, no, 0.5. So what was the pendulum? The time it takes to complete 20 oscillations, 10 oscillations at 15 degrees. Remember, it was at 14, right?
14 seconds, sir.
Yeah. So we now move this to say, let's move it to 60 degrees, and let's do the same thing over again. So it was at 14. Now we look on it at let's try it at 60 degrees. So we play it, and then we're going to start it when it reaches here. When it goes over here and then returns back, that's time. That's the time. That's one oscillation. All right. So let's watch it. So go and start it. No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So you realize now that it was at 14 at first, and now how much is it at?
15.
Yeah. So it takes a longer time if you have a larger angle. So it was at 15 at first degrees, 15 degrees,
Yes,
and we
sir.
move it up to 60 degrees. It takes a longer time. That's what I want to accomplish. No, let's put
Yes.
it back at 15 degrees. And now we look on the mass. Let's change the mass. Yeah, let's change the mass of the object. So it's at 1 kilogram. Let's put it to 1.5 kilogram.
Oh,
And you realize it get bigger, slightly bigger, right?
yes, sir.
And let's start again at 0.5, right?
I believe it's going to slow down.
You believe you're going to slow down? All right.
Yes, because of the
So,
weight.
all right. Who else believe it's going to slow down?
Yeah.
What do you say, Heinz? It's going to speed up or slow down?
Sir, what did you say, sir?
If we
So
have a
it's gonna
larger mass.
speed up and slow down.
All right. All right. Let's try it out.
Go
Let's
slow.
try it out. All right. So it was at it took 14 seconds, right? Remember when you did this at
Yes.
first?
Sir.
All right.
Yes,
Let's try
sir.
it again. So we're going to start when it reaches here, and then when it goes over here and comes back, we count at 1. All right. Start. 1,
1,
3,
2, 3,
4,
4,
5,
5, 6,
7,
7,
8,
8,
9,
9.
10. Right. So we see that it doesn't really changes. It was at 14 at first. I know it's still at 14, right?
Well.
The
Well.
mass
Can't
does
say nothing
not.
about that.
The mass does not affect it. You see that?
Yes, sir.
All right. Now let's go. Let's put this back at 1 kilogram, and let's start this over. Then let's go on. Let's go on the moon. Let's try it on the moon. Let's see what's happening on the moon.
Wow.
All right. Let's see what's happening on the moon. So we place it back at 15 degrees. So we're doing this experiment now on the moon. All right. Let's try it on the moon. So the moon is much smaller. So therefore, the moon will have a smaller gravitational force. So therefore, we'll see what happens if it has a smaller gravitational force. Because the moon is much smaller, that's why you find that when people are on the moon, they jump up and down. Right? There's little gravity. All right. So let's try. Let's see what happens. All right. We see that it moves much slower. It started when it reaches here.
Way much slower.
Much slower. So we can see that 1. So we see that it moves much slower, right? 2, 3. We're not gonna count the whole time because it might take us for the rest of the day. 4. See, it passed 14 seconds. All right. So let's try this now on Jupiter. Let's go on Jupiter. All right. What do we see now?
Sir,
Moving fast.
Yeah. Yes, because Jupiter is much
sir, look
bigger
like
than the Earth.
Jupiter don't really have any gravity.
Yeah, Jupiter has gravity.
So it moves-
It's much
no, it
bigger.
doesn't have a lot.
Sir, the speed increase.
Like how Earth has a lot of gravity. So
All
anything
right.
that go up just come straight down. Jupiter, it takes a while for the object to actually come down.
That's not the
That's
I'm
why
going
case.
to
it
live
start
in
moving so
Jupiter.
fast.
That's not the case. Let me tell you why. If you can remember from grade 9, you can remember from grade 9.
Grade 9.
Yeah. Oh yeah. No, well, you're going to do it.
Grade
You're going
Yeah,
to
9.
do it.
grade.
We
You do it from the
die.
earlier in grade 9. We spoke about I believe what is that? Sir Isaac Newton. Remember
Oh,
that?
yes.
Remember we
Yes,
spoke
sir.
Oh,
about earlier in grade
yes,
9,
yes, yes.
and we spoke about the
Yes, sir.
law of gravitation, right?
Cool.
Yes, sir.
Yeah. So
Yes.
the larger
Sir,
an
I'm going back
object,
to the
the more gravitational force that it will have, and that is the case. But we don't need to focus on that right now. That's just for information. All right. So let us get back
yes,
to where we were. Let me try and get this. Keep. All right. All right. So we completed this, and we saw that as we increase the length, it took a longer time, right?
yes, sir.
Yeah. And if we increase the angle, it took a longer time, right?
Yes,
So we
sir.
increased
Yes, sir.
degrees to say 60, and we saw that there was a big difference. Now, what happened when we increased the mass? Were there any changes?
No, sir.
All right. So that's what we want to accomplish, and that's exactly what's on here. So this proves that as the length of the string increases, the period of oscillation also increases. The time it takes to complete the oscillations will increase, right? And as the amplitude increases, the period of oscillation increases. Are we all clear?
Yes, sir.
All right. As the acceleration due to gravity increases, the period of oscillation decreases. Now we'll talk about this for a few seconds, right? If we have a ball here, right, in the air, and it is 2 meters away from the ground, and we let go this ball, what will happen? Will it go up or down?
No.
Down due to the
Yeah.
gravity.
Why? Because of gravity, right?
Yes.
Yes, sir.
So gravity is that force that causes the ball to accelerate downwards, right?
Yes, sir.
So this will be G. So the acceleration due to gravity is considered G. So if the acceleration due to gravity increases, say we go on another planet with a larger acceleration due to gravity, we will find out that the period of oscillation will decrease. It will take a shorter time. Basically, the pendulum will be moving quick, as we saw in the experiment a while ago when we took a trip to Jupiter, right? We saw that there was an increase in the speed or how fast the body was oscillating. All right. And the last one is that I made this very clear, right? You're going to get questions on this. I tell you from now, the mass of the bulb does not affect the pendulum. All right.
Yes, sir.
All right. So I believe it's your lunchtime in 3 minutes.
Sir, could you
So
do my message in the chat, please?
you sent a message in the chat.
Yes, sir.
Okay, message me privately. All right.
Yes, sir.
All right, message me privately. All right, everyone. Remember that we have class after this. All right.
Yes,
In
sir.
that time, I will give you an activity.
Oh God, sir.
Yeah, I'll give you an activity no, I can't give you the activity as yet. All right, so we'll meet back here after lunch. Okay.
Yes, sir. Yes, sir.
All right.
Yes, sir.
All right. We'll meet back here after lunch. All right. Bye. Goodbye,
Yes,
everyone.
sir. Bye.